If everyone's seeing my slides, not me. Yeah, I assume you are. And yeah, this is work with Simon Sharp in the COP26 unit in the Government Cabinet Office here in the UK. And what I want to do is really talk about how can we take some of the principles of tipping points and possibly even some of our early warning methods and actually apply those towards identifying the positive tipping points we're going to need if we're going to accelerate decarbonisation to the point where we can actually limit global warming to well below 2 degrees C, or at least stand some chance of doing it. So I think this same conceptual toy model of systems with alternative states that may be forced past a bifurcation tipping point, or indeed a rate-induced or noise-induced, or what was it the other day, a shock-induced tipping point. All of these concepts can, just as they can be applied to identifying tipping elements in the climate system and seeking warning signals, they do have some real mathematical parallels in relevant social systems that we're going to kind of need to tip if we're going to avoid the worst of climate tipping points. The other thing I would say that probably many of us have learned from looking at the Earth system and the climate system is this idea that tipping points can interact, and sometimes they could interact in a bad way, that they cascade, that tipping one increases the likelihood of tipping another. And in this talk, I'm particularly interested in tipping cascades that can proceed upscale in time, in space, and across sectors of the economy. It's going to be in a minute. And that's upscale tipping, if you like, cascades, could be what might be possible in the climate system, but let's hope we're not too close to one of those. So just to set the frame, if we want to have a good chance of limiting warming to well below 2 degrees C, we need to be on the red line here with the red uncertainty range around it. So we need to get to global net zero greenhouse gas emissions by roughly 2050. The rates of social, technological, economic associated change that implies are truly spectacular at this point. 5 or 7% per year-on-year reduction in emissions. I think there's no feasible way we could get there without some very strong non-linearities in that social technological realm, which is what I'm going to talk about. And I'm not the only person banging this drum. So Jonathan, who's been on the call, and others published some nice paper earlier in the year conceptualizing the need to find these tipping points to accelerate decarbonisation. And I want to be concrete about the fact that there are some that we can already see happening, and talk about what interventions could tip them to happen faster. Just to say a word more about tipping cascades, though, this is not like a new concept. If you know some ecology, the idea of what are called trophic cascades in ecology is extremely familiar, and they can go in good or bad directions. So a classic idea is that if you take out a keystone species like the grey wolf from Yellowstone National Park, it has consequences that cascade right through the ecosystem, and in that case totally transform the type of tree cover. And then if you bring the wolf back, you also have, in that case, positive, inverted commas, cascading consequences through the ecosystem. Equally, one might argue that some past mass extinctions involve bad tipping cascades to have become as extraordinarily devastating as they were, because it's not at all obvious why the amounts of carbon that were injected from volcanic eruptions at the end Permian period, for example, could ricochet, somehow cascade upwards to eliminating well over 90% of species. So yeah, there are cascades in the Earth system, I think, occasionally. There are cascades in ecological systems, but what we want is we want tipping points, and we want cascades in social and technological systems. So here's a historical example of a tipping point of social and technological change. And there are several of these in a whole field called social technical transitions, which is a bit of a mouthful. This is Easter Parade, Fifth Avenue, New York City in 1900. Everybody's in a horse-drawn carriage except for one person in an early automobile. And 13 years later, everybody's in an automobile and one person's left in a horse-drawn carriage. So that transformation in personal transport happened across US cities within a decade, and of course spread pretty rapidly upscales around the world. We probably look upon it with mixed feelings today, given that the cars have got internal combustion engines running on fossil fuels. But in a minute, we'll come to the fact that there's another type of car that could rapidly take over in the near future. So that was one historical example. It serves to introduce the idea that there are well-known reinforcing positive feedbacks in what's broadly called technology diffusion. And of course, strongly self-amplifying positive feedbacks are exactly what you need to propel tipping point change out of an attractor that has lost stability into some other attractor. So here are my plain English language phrases for three well-known types of reinforcing feedback. The more something is made, the better it can be made. We call that learning by doing. The more something is made, the more cheaply it can be made. That's super important. That's economies of scale. But also, the more something is used, the more technologies emerge that make it more useful. All three positive feedbacks are well known in this field of technology diffusion and will be crucial if we're going to get to net zero quickly. And then there's what Martin mentioned, was it yesterday? This idea of social contagion, that of course, sometimes ideas or norms spread rapidly through a population, as do the uptake of new products sometimes, which is pertinent here. And an example actually is the uptake of solar panels on people's houses. So I'm just going to show you a little video of about 4 years in a part of the US where you see social contagion with respect to the solar panel uptake. Basically, social contagion is all about how we are influenced by what our neighbors are doing. Neighbors in a literal sense here, but of course in an interconnected, interneted world, our neighbors don't have to be physically next to us. The point is we respond to social influences and sometimes choose to imitate or follow what others are doing. And this can cascade upscale quite dramatically and rapidly. A good thing in this case for this technology. So now what I want to get into is, okay, where are there some other evidences of real tipping points to decarbonisation starting to happen, and how to conceptualize the tipping dynamics? I'm not sure this is the perfect metaphorical approach, but basically there's this widely held belief in the economics of climate change that I think is totally wrong, which is that the harder you want to abate emissions or reduce greenhouse gas emissions, the more you want to do that, the more it's going to cost you. So the marginal abatement cost goes up, the more emissions you want to cut out or abate. So you're trying to push this boulder up a hill, and frankly, the hill's getting steeper the further you push it. Well, we're completely doomed if that were true, but I don't think it's true. And I think it's quite clear that the dynamics are different and non-linear. And in fact, there is a top to the hill in this metaphor, and then the boulder will just happily roll down the other side once you've tipped the system past that, you might call it unstable, steady state at the top of the hill. So let's make that concrete with a couple of examples. I'm going to start back with cars, but this time electric cars, because one nation has succeeded in tipping electric vehicles into being the most popular form of car purchased, and that's Norway. And they've done that by several means. I mean, so there's some underpinning things I put on the slide here that have been going on globally, of course, in research, development, deployment of electric vehicles, economies of scale, prices starting to come down. But then there's some very clever policy interventions in Norway to support the uptake of electric vehicles. And then on top of that, there was a genius design of a tax incentive system in Norway that basically made electric vehicles equivalent in price to a petrol or diesel car for the purchaser. And then you see the consequences here in the data. So I'm plotting the cost differential on the x-axis between a petrol or diesel car and an electric vehicle for different European countries. On the y-axis is the market share, purchase share of EVs, electric vehicles. And my data is out of date. So Norway's now at about 2/3 purchases are electric vehicles, not a half. And it would appear once they're, cost parity to the consumer with a petrol or diesel car, sure enough, they're actually the more popular choice. And there's evidence that social contagion has been happening in Norway, at least. And there's been this switch over to EVs. So far, so good. But how could we cause that tipping point to cascade up scales? Well, clearly, what we would like to get to is a point where, without any subsidy or clever tax incentive, the electric vehicle is the same price and ultimately cheaper than the petrol or diesel vehicle. And the good news is that point isn't far away, thanks to the positive feedback of economies of scale, principally on the cost of batteries that are a key part of the cost of the vehicle, shown there on the left with the sort of paley, yucky green wedge that's declining in size. And on the right, we see this classic economies of scale thing. The more batteries you make, the cheaper they get per unit. And that trend is continuing. And it means that within about 5 years, without any sort of differential tax incentives, EV will be cheaper than a petrol or diesel car, and it carries on getting cheaper after that because it's got less moving parts that wear out slower and so on. So we're going to tip to electric vehicles pretty soon anyway, but we want this to happen as quick as possible if we believe in the need for net zero as soon as possible. So there's a tipping point I've mapped on here that where the electric vehicles become cheaper than the petrol cars in major economies, and policy can make that happen sooner, as in the case of Norway, and then achieve world-leading rates of decarbonisation. And I would argue 3 nations, or jurisdictions I should say, have got a vested interest in getting together to make that transition happen sooner. And that would probably be China, the whole EU bloc, and California. And together they sell more than half of the cars that are sold in the world. So they tip the global market just like that. And then the really interesting thing is, of course, the following positive feedbacks that kick in, the reinforcing feedbacks that kick in. Because in all of this, if you have an electric car revolution, then you're going to bring down the cost of battery technology, and that's going to open up other opportunities. It's going to open up the possibility of tipping point for electric lighter trucks. It could trigger this tipping point I put down the bottom around when do oil firms finally quit on oil and diversify their investments and their strategies. And perhaps most interestingly, by making battery technology cheaper, that's really useful if our aim is to have a renewable energy electricity supply in the future, because of course battery storage is vital to even out the uneven supply of renewable power from the sun and the wind. And that's what I want to come on to next. My second example is basically the rise of renewable electricity, and how can we tip a cascade for that to happen globally faster. And the good news story that those of us in the UK can feel good about is that we've basically tipped coal out of UK electricity generation, and I'll show you a little bit about how that's happened. So of course there's global research, development, deployment of solar and wind power over decades, and then in the UK case, as in many other nations, there have been subsidies and power sector reforms to boost the renewable energy capacity. You see on the right there, the blue curve. That's great. That's helping sort of take the gradient of the hill over a bit here, because what it does in literal terms is the more, once you've built a renewable energy installation, you're not having to pay for any fuel, right? So basically, once you've had the capital cost of putting it in there, whenever it's generating power, that's the first thing that comes in what's called the merit order here, of which fuel source do you use to meet electricity or power demand in red with the big red dashed line. And at the top, you've got basically the traditional merit order, which has this unfortunate thing that coal is cheaper than gas for electricity generation. So having used whatever renewables you've got on stream and whatever nuclear you've got on stream, next thing you would go to is coal, unless, of course, you do something about to penalise the price of making electricity from coal power. So just to step back a bit, the first thing that happens, you boost renewable energy capacity, you're shifting things over in the merit order. So you might be pushing, in this case, the hard coal out of electricity generation, but you're still using the lignite coal. But then what happened in this country and other countries is deliberate carbon pricing to penalise coal, because for the same amount of electricity generated, you'd have about twice the CO2 emissions off if you make it from coal burning than from gas burning. So a carbon price can essentially switch coal and gas around in that merit order. And this is what the UK government deployed. It wasn't with as much foresight as it looks like when I present it this way, but essentially there's been a price on carbon emissions in the power generation from the EU for quite a while, and that's the grey shaded area. The UK government has deliberately introduced an additional carbon price just in the power generation sector, and that's the blue hatched area, and they've stepped the price up over time, as you can see. And then red here is what's called the coal to gas switching price, the point at which it becomes, in the merit order, it makes sense to use gas to generate the electricity once you've kind of got all you can from renewables and nuclear, rather than coal. And that tipping point seems to have been crossed around the 2015-16 crossover point in the UK. And it acted on top of those other drivers to really change things around in our energy system. So here I just schematically put gas leaping ahead of coal in the so-called merit order. But then it had this larger consequence. It wasn't just like a short-term thing where you turn on the gas-fired power station rather than the coal-fired one. It tipped a larger system. The whole economics of coal power started to look not good, and then the various actors in the economy started making irreversible decisions to destroy, in this case, a coal-fired power station in Oxfordshire. This one, near Chris, I believe, if he's still on the call, and it's in Didcot in Oxfordshire. So we had a small-scale tipping point in the merit order, then a larger tipping point, if you like, where coal becomes loss-making rather than profit-making. And those two things, together with the push for renewables, has basically tipped coal out of UK electricity generation. And this is striking, because in 2012, it's still 40% of our power generation, and now it's down to less than 2%. And most of the slack is being picked up by renewables, as you see there. So then the question is, how does this go global, or what can cascade the global transition to renewable energy? Well, again, let's go back to the positive feedbacks. Great news on the positive feedback of economies of scale, which is that the price of solar PV cells is just on this spectacular downward trajectory. The more of them we make, the cheaper they get per unit, and they're already undercutting everything else. And then it's set to get to the point where in about a decade, some forecasters have it that electricity production from solar PV cells could be a fifth of the price from fossil fuels. So that totally changes the game. So what we're seeing and the cascade that we kind of will happen, but we want to happen as fast as it can in the global context, is first of all, we get to a point where what's called new for new. Do I build a new fossil fuel power station, or do I build a new renewable installation for the same amount of energy generation? That tipping point is already passed in several nations, as we'll see. Great, that increases the renewable deployment, and as deployment goes up, economies of scale, costs come down, and then we need to get to the second tipping point, which is where it makes sense to actually decommission an existing coal or gas plant with useful life left in it and replace it with new renewables. And it depends from nation to nation, but even for the case of China, that's about 10 years away for coal, but it's about today already for gas power. So good news there. How do we tip it faster? Well, there are some problem issues here. In fact, one of them is that to raise finance for new renewables for a given amount of capital, raising the capital you need to install a given amount of capacity is more expensive or more difficult still for renewables than fossil fuels. So the finance sector could do something about that, as could the two minutes earlier, as could the three nations that are still their banks are the main investors in new coal-fired power stations. That's Japan, China, and Korea. So if they would make a pact together to stop doing that, to stop financing new coal power, things will happen faster. The reason they don't make a pact on that at the moment is they think if I don't invest in this new coal power station in Africa or whatever, one of the other two will. Well, they could make a coalition to stop doing that. And there's a certain irony anyway, because in China, as you see on this map, as in much of the world, actually, when you take out all the subsidies from the calculation, the cheapest form of electricity generation in China and in much of the world is already renewables. It's solar in the yellow colors, or it's wind in the blue colors. But of course, there's that great big sort of not covered area, including much of Africa, where the crucial thing here is, can we tip the transition to be one straight to renewables, bypassing the fossil fuels? So reasons for hope there, I think. And also, as a final thought, got to remember again the positive feedbacks here. So this renewable revolution in electricity generation, that helps support the transition of transport to electrification, which, remember, was helping bring down the battery cost, which was helping make the renewable electricity future a more viable option, because you needed those batteries to even out the supply and demand unevenness from renewables. Ergo, another positive feedback loop, another nonlinearity to help propel change. Well, that's probably my 20 minutes. You can read the summary. The simple message is, to avoid the bad climate tipping points, we need to identify and trigger these positive social, technological, and I would say also ecological tipping points. I've shown you some examples where well-designed tax and subsidy policies from particular governments had a huge non-linear impact and achieved world-leading rates of uptake of electric vehicles in Norway and world-leading decarbonisation in the rates in the UK. And surely that's what policymakers want. They want a big bang for their buck. And I hope I've also hinted at how small groups of countries getting together in coalition could trigger a tipping cascade faster for some of those systems. Thanks very much.